What we're going to take a look at in this video is polynomial functions, what they are, and how we can identify them versus other kinds of functions. This slide here is going to be all of our important information and verbiage that we're going to need moving forward. So what a polynomial function is would be in this format. Now, what a polynomial function really is going to be is really any sort of function that has exponents that have positive whole numbers and that have coefficients that are real numbers. So if I look at, for example, a quadratic function, I'm going to have x squared plus x plus 1. This would be seen as a polynomial because each coefficient is a real number. I have a coefficient of 1, and then constant of 1, and all my exponents are positive whole numbers on that. And really kind of why we use polynomials, because now instead of looking at things just like x plus 1 or x squared plus 1 or x squared plus x plus 1 or something like this, now we want to look at things like x to the third, x to the fourth, x to the fifth, because those are going to be functions that we're going to have to use, and we need some way to go through and describe them. So this is going to be more useful for a function like this, x to the fourth minus 3x squared plus x minus 1. Something like this. That would be considered a polynomial as well. All of our exponents are positive whole numbers, and our coefficients are all real numbers here. Now, just kind of a little bit of the verbiage for what we have going on up here. Looking at this first off, standard form. Anytime we write a polynomial in standard form, it goes when the terms are descending of order of the exponents from left to right. So looking at this here, I go from x to the fourth to x squared to x, and then x to the 0 or no x term. So going from left to right, we start with our biggest term on the left and we would go down to the right. So if I had x squared minus 4x to the third minus 1 plus 8x to the sixth, that wouldn't be in standard form right now, because if I look at that, it's not in descending order in terms of the exponent. So if I want to change that, I could just go through and say, well, x to the sixth is my highest exponent. I would subtract 4x to the third because that comes next. I would have x squared, and I would say minus 1. Those two functions are the same exact thing. It's just the second one ends up being in standard form. Now, just a few other pieces of this. What we say a naught up here. A naught is just going to be the constant term. So that's going to end up being useful down the road. What's going to be something that's very important is the leading coefficient. So what the leading coefficient is going to be is the coefficient that is before the x term that has the highest exponent to it. So, for example, I'm going to look at this one here. X to the fourth minus 3x squared plus x minus 1. The leading coefficient of that here is 1. All right, it's the coefficient in front of the variable that has the highest exponent. Now, if I look at this example down here, x to the sixth is the highest exponent, so its lead coefficient would be positive 8. And that's kind of where some people get tripped up in the concept that, well, up here it looks like 1 would be the lead coefficient. But it's not, because it's not really written in standard form. So when I have something written in standard form, the first constant that's going to be in front of the x variable with the highest exponent, that's going to be my lead coefficient. And that's going to be important when we get to graphing, looking at what it is, if it's positive, if it's negative, things like that. Now, the last piece of information that's important is the degree of our polynomial. The degree of our polynomial is going to be the highest exponent that we see in our polynomial. So, for example, we'll go through the few of these ones. This x plus 1 here would be seen to have degree 1. The highest exponent on a variable would be x to the first. This would have degree 2. X squared is the highest exponent. This would have degree 4. And both of these would be seen to have degree 6. The highest exponent on any of the variables would be 6. So degree is going to be very important. Identifying the highest exponent don't mind that. The highest exponent on one of the variables. Lead coefficient is going to be the coefficient that goes in front of the x variable that has the highest exponent. Or I'm sorry, that is the largest exponent. So in this example, like x to the sixth. 8 would be our lead coefficient. And then constant is just going to be the term that's at the end, typically, that doesn't have any x attached to it, just some sort of constant added to our equation. So just a few of these common ones that we end up seeing. If I have degree 0, I'm going to have no x term. So it would just be, my function would be something like y equals 5. Y equals 5. And we saw, or we should have seen while ago, the basic shape of that is just going to be, it's going to be linear, but it's going to be a horizontal line. Now, something like this, degree 1, for example, would be an equation like x plus 2. The basic shape of that is going to be linear, and it's going to be described as linear. We have a degree of 1. It's going to look something like this straight line on some sort of, either rising up, rising down, positive slope, negative slope, all those different things. Quadratic function is going to have a degree of 2. Cubic is going to have a degree of 3, and a quartic is going to have a degree of 4. So if I have my highest degree is 3, like this, 3x to the third minus 1, that would be considered a cubic function. And same thing with quartic. If I had negative 4x squared plus 2x to the fourth, looking at that first off isn't in standard form, so I'd have to put it in standard form. Make that 2x to the fourth minus 4x squared. Now looking at that, the highest exponent that I have would be 4, making this a degree 4 function when I look at this. And that's going to be important when we get into graphing, identifying, when do I have cubics, when do I have quartics, looking at what the lead coefficient is and what the degree of the function is going to end up being. One last thing, just looking at this here, which of these are going to be functions? What we have to look for is, 1, do we have exponents that are all positive whole numbers? And then do we have numbers that are real numbers as coefficients? So looking at A, all of these criteria are met. I have an exponent of 2, 4, and 0, and 1/2, negative 3, and 7 are all, or negative 7, are all are all real number coefficients. Now, so that's going to be a polynomial. What it's asking us to do here, write it in standard form. So to write it in standard form, I'm going to move this around, and I'm going to put it in descending order for the variables. So what I would end up having, negative 3x to the fourth plus 0.5x squared minus 7. Its degree, or n value you'll see a lot of, would be 4. That's the highest exponent within the function. Its lead coefficient is that coefficient that goes in the front of the x to the fourth term. So that would be negative 3. And what else are we looking for? The type. Its type would be quartic. Alright, just because it is a fourth degree function. Now, that's everything describing all of the pieces of that polynomial function. Part B, looking at this would not be a polynomial because of this term right here. I have an x in the exponent. That's, that is not a positive whole number, so that's done. That would not be seen as a polynomial. Looking at C, the same sort of idea. What the term that messes me up would be this one here, because I have an exponent that is negative. It has to be positive whole numbers and in the exponents, and we have to have real numbers that are in the that are coefficients. So that would also not be a polynomial. Now, if I look at this last one, looking at this, what this is really saying is I have negative 1/2 x plus pi times x squared minus the square root of x. Alright, looking at this one is, it looks pretty good here. It looks pretty good here because pi really is a real number, so that wouldn't restrict us at all with that. What does hurt us is the fact that we have the square root here. Right, that square root of x, that is not giving us an exponent that is a positive whole number, and it doesn't really matter what the coefficient is. And what you guys will end up learning down the road is that ends up having an exponent of 1/2. That isn't something that we've gotten to yet, but we'll end up changing that from square root of x to the 1/2. Looking at that, that's not a whole number, that would be a fraction. So this would not be a polynomial either. But what's going to be important, if we look back at question A, being able to write it in standard form, like we did, being able to identify the degree or the highest exponent on any of the variables, identify the lead coefficient, the coefficient in front of the term with the highest exponent, and then identifying the type. And to identify type, we look back at these ones. These are the ones we're going to have to know. We won't have to know degree 5, 6, 7. We will have to know constants, linear, quadratic, cubic, and quartic, because that's going to be verbiage that we're going to use in class frequently.